So today we're discussing about transport layer protocols. That means what are the different ways in which sender can send data to the receiver. So we have 5 different protocols here: simple, stop and wait, go back and selective repeat, bidirectional, also called as piggybacking. So we're going to discuss in detail about these protocols. So let's move on to the first one, simple protocol. So as the name says, it's just simple. So in the previous sessions or in the previous videos, we have discussed this. There is a limit in which receiver can handle data that is being sent by sender. That means if there are any compatibility issues between sender and receiver, if sender is sending more data that receiver can't handle, then we will be sending some flow control back to the sender. So it's not the case here. It is like infinite amount of data, an infinite amount of capability the sender can send and the receiver can handle. The sender will be keep on sending data to the receiver and receiver can accept it. So it is a connectionless protocol further. So here you can see that request came from the application, packet arrived, it's just the same. So here you can see there is a request and this is the arrival. Although there is a sort of delay here as it is a connectionless server. So this is one type in which sender can send data to the receiver. And the other thing is stop and wait protocol. So let's say that it is a bit of connection oriented protocol in which there should be handle the case of whether the data is received or not. So let's say that if the data is not received, if it is missed or if it is corrupted, then it is not reliable. The data should be sent again. So at that time, we'll be calling this protocol in the transport layer, that is stop and wait protocol. As the name suggests that whenever a data packet is corrupted or missing, the receiver stops and will be waiting for some time. And if the receiver didn't give any acknowledgement, acknowledgement is a very crucial thing here. If the sender didn't get any acknowledgement from the receiver, then sender will resend the data again. So let's say that here, so you see that, so whenever in the transport layer sender is sending some data with a sequence number and a checksum, as checksum will be used to detect whether there is an error in the data or not. So when the receiver receives the data, if it receives it correctly, then it gives an acknowledgement to the sender, denoting that I have received the data correctly, send me the next bit of data. So whenever sender got the acknowledgement from the receiver, it sends the next data. Otherwise, it will not send. So in this situation also, we have 3 scenarios. First thing is the packet arrived to the receiver safely and the receiver also sent an acknowledgement denoting that everything was fine. The sender should send the next data. The second scenario is the packet is corrupted or it is missed or it never reached the receiver. Then what will happen? As the receiver didn't got any information, it will be not giving any acknowledgement. So the time will be out. So when the timer is out and it didn't get the acknowledgement for the next data, sender will resend the same data. That's the second situation. And the third one is the sender have sent the data, the receiver have received it, but the receiver failed in giving acknowledgement or there is some error in the acknowledgement. So the sender didn't get that acknowledgement. Then what happens? Sender will send the next data only after receiving the acknowledgement. As it didn't got the acknowledgement, it won't give it. I mean, the same data will be sent again. So here the main important thing is the packet here is duplicate, because let's say that you sent a packet 3 and somehow you didn't get the acknowledgement, then the same copy of packet 3 will be sent again. So that's a bit of problem, we'll discuss further. So how the acknowledgement numbers are used. The acknowledgement numbers are basically used to get the next bit of data. So here in the second point, you can see that if the packet 0 has arrived safe and sound, the receiver sends an acknowledgement with 1, meaning that in the next, packet 1 is expected. So the crucial part in this acknowledgement thing is whenever receiver is sending an acknowledgement, it tells that I am willing to accept the next part of the data. So that's what, if it is 1, that means the process have very good approach, it is being safe and sound. But if the acknowledgement is 0, that means he didn't got the packet corrected. So that's what the stop and wait protocol is. So here you can see the block diagram. This is the checksum about it. So here we can discuss more clearly. Packet 0 is sent, acknowledgement 1 is given, that means it will be having the next data. It is very clear and concise. So here the start time and end time have been just completed, and when the start time, the other packet is being sent, and if packet 1 is sent and in between it is lost, that means timeout, because the timer has run out, and then the packet is sent again, and that time acknowledgement is also received and the process stopped. Okay, no problem. Then package is sent but the acknowledgement is not received. Since sender didn't got the acknowledgement, the timer is out and it is sent again, that means resent, and acknowledgement is got, so it works fine. So the problem here is, however, the network layer in the receiver side receives two copies of the third packet. So here you can see that at first the receiver got the packet of 1. As the acknowledgement is not received by the sender, there is no problem with the receiver. As the acknowledgement is not received, the sender is sending the same data again. So it's a sort of problem here. So that's the problem with stop and wait. And next thing is with go back N protocol. So go back N protocol is a type of sliding window kind of thing. So here we'll be starting with the pipelines. So here you can see that there is an application layer and also a transport layer. When the transport layer is sending data in terms of batches. So in the last diagram, you can see that. So at first here the PPT might be misguiding you. When the window size is 4, the sender sends 0, 1, 2, 3 data to it, and at first receiver receives 1. So after receiving 1, the window will be changed to 1, 2, 3, 4. So after receiving the 1 also, the window will be changed to 2, 3, 4, 5. But whenever there is a problem in getting acknowledgement for 2, in this kind of protocol, this whole window is resent again. That's the main thing here. That's what just go back N protocol is. In the entire window, if the first one is not received, if there is a problem in receiving in the first one, then the entire window is sent again. So that's what go back N protocol is. So here you can see the example, and next one is selective repeat protocol. This go back N protocol and selective repeat protocol are typical kind of sliding window protocols. So there is a very slight difference between selective repeat protocol. Here you can see that. So just go from the beginning. The same sliding window is applied here. 0 is sent. Whenever 0 is reached safely, it gives the next acknowledgement for 4. And next, the 1 is also reached safely. That means the next one will be 5. And now the second one is not reached. I mean, the second packet is not reached safely. Then the entire window is not sent again. So this is what the difference between the n-back and selective. In the selective thing, we will be sending the data which is only corrupted. So if you go to the next figure, you can see that here only second one is discarded, but you can clearly see that 3, 4, 5 packets was sent and only 2, 6, 7 will be resent again. So this is the difference between the selective and go back n. So observe very carefully. Here we will be resending 2, 6, 7 packets, and here whenever there is an error with the second one, 3, 4, 5 packets were continued normally. But if you just go back to this n back, go back n, here you can see that 3, 4, 5 were distributed or was sent entirely again. So it's the only the difference. The sliding window part was the difference between this go back and the selective one. So here are some example, and the next one is bidirectional protocol, also called piggybacking. So it's a very simple protocol. In our daily lives, in a real life problems, the sender and the server, or we can say that the sender and receiver will be sending data, and they should also get sending acknowledgement and receive acknowledgement. So in this bidirectional protocol, in this third point, you can see that when data is being carried out from A to B, it can also carry some acknowledgement feedback which is arrived from B. In the same way, when packet is carrying data from B to A, it can also carry the acknowledgement feedback which is arrived from A. So that's what in this figure you can see that the sender is sending data along with checksum and also acknowledgement number and sequence number. This acknowledgement number will be added to the packet. So client is sending some data, and along with that data, as it is getting data from server, it is also giving that acknowledgement whether it received the data correctly or not. Well, so that's what the acknowledgement number says, that right. So in the same case with the server, when server is sending data, it's also giving some information to the client along with the acknowledgement number. So this piggybacking is what we'll be using in the real life problems. So that's it about these transport layer protocols. What so far we have discussed these three, I mean 6 kind of protocols, which it is simple protocol. I mean infinite amount of data will be transferred between sender and receiver. Stop and wait protocol, here where we have introduced the term called acknowledgement, and go back end protocol. So from here the sliding window part will be introduced, and if the front part, I mean like if the first data packet was corrupted, then the entire sliding window will be resent again in this go back end protocol. But in the selective repeat protocol, if one packet of the sliding window is corrupted, remaining will be transferred as it is, and only the corrupted part and the next sliding window will be transferred. So instead of transferring the entire data again and again, so that's the slight difference between this and bidirectional protocol. Piggybacking is used in real life problems. So that's it about the transport layer protocols, and see you in the next lecture.